Hello students, in today's video we will be discussing about relations and functions, and in the previous sessions we discussed about relations, and now in this session we will be discussing about function and its types. So what is function? Function is nothing but when we describe a function in terms of a machine. Imagine this is a function which has a machine, and this is f of x. Provided for every input value there will be a unique output value that is called a function. So imagine with the sets, this is set A and this is set B. Imagine they are non-empty set. Okay, for example 1, 2, 3, 4, 5, 6, 7, 8. So each element are associated uniquely with the set B. This is called a function. Each element are associated with the element in set B. So this A to B, a function which is denoted as f from A to B, when we say it is a function, for every element in A is associated with the element in B, hence f is termed as a function. It is a rule. So where set A is denoted as domain, since we discussed this in relation, and set B where 5, 6, 7 alone are associated with A, this 5, 6, 7 are termed as range, and the whole set B is termed as codomain. So these are the terminologies which you are dealt in your relation itself. The same thing we'll be discussing in your functions. So we'll be discussing in depth the definitions. So what is a function? It is a relation f from set A to set B. It is a relation from set A to set B. It is said to be a function if every element of set A has one and only one image in set B. In other words, a function f is a relation from a non-empty set A to a non-empty set B such that the domain of f is A and no distinct ordered pair in f have the same first element. So that means, with an example, if this is set A and this is set B, the ordered pair, this is set A, non-empty set, and this is set B, 1, 2, 3 and 4, 5, 6. Suppose 1, 4 and 1, 5, 2, 3. So here when I am writing this in the ordered pair, I will be writing it as 1, 4, 1, 5, 2, 6. I can say this is a relation, but it is not a function because 1 is having 2 images. Henceforth, this is termed as a relation, but it is not termed as a function. Similarly, 3 is not having any image. Okay, so what is called an image? The set A is termed as a pre-image and set B is termed as an image. So set A is termed as pre-image and this is an image. For every image there will be a unique pre-image. So here 3 is not having any image, henceforth this is not termed as a function. So we'll see a few more examples. Suppose in this example, examine each of the following relations given below and state whether in each case giving reasons whether it is a function or not. So look at the first thing. So R 2, 1, 3, 1, 4, 2. 2, 1, 3, 1, 4, 2. Each element, look at the first component in the ordered pair are termed as domain. So each value are distinct. Leave about your range because it can be even same. It doesn't matter. But each element in the first ordered pair should be different, distinct. So 2, 3, 4. The elements on the domain of R having the unique images in this relation is termed as function. So the first one, it is termed as function. Look at the second one. 2, 2, 2, 4, 3, 3, 4, 4. So here the first component 2 is being repeated. Therefore, it cannot be termed as a function, whereas it is a relation. Since the same first element 2 corresponds to 2 different images, 2 and 4, this relation is not a function. Look at the last one. 1, 2, 2, 3, 3, 4, 4, 5, 5, 6 and 6, 7. So all the first component are distinct, henceforth we can conclude that it is a function. So every element has one and only one image. This relation is called a function. So with this we are, make sure that you should be differentiating between what is relation and what is a function. So students, next we will be discussing about types of functions. So one by one. So what is called real value function or real functions? So real valued function is nothing but, since we discussed about set A, so you should, by this time you should be very clear with your definition of functions. So when the set, this is called domain and this is called codomain, because the function is traveling from set A to set B, means this A becomes your domain and B becomes your codomain. When the domain is nothing but is a subset of real numbers, or domain is equals to real numbers, then we say it is a real valued function, or in short it is called that when the domain and the range or the codomain are a subset of real numbers and equal to real numbers, means then the function is termed as real functions. If suppose only the range is a subset or it is equals to real number, then we termed it as real valued function. So real function and real valued functions. So real function means, suppose when the domain if it is fixed to the real numbers, then we say if domain is a subset of real number, then we say it is a real functions. So this is called real valued functions. We'll be discussing about some types of functions in 11 standards. In 12 standards, we'll be discussing about few more types, many to one function, one to one function. So these are all we'll be discussing in 12 standards. So next types of functions we'll be discussing about identity function. So what is an identity function? So now hereafter domain and range are real numbers. So f is from R to R. So that means real number, it is a real function. So every functions will be terming it as real functions. From here onwards, what is identity functions? Suppose when f of x is equals to x, this is what the definition for identity function. F of x is equals to x. So when it is a function, then we can plot on the graph. All the graphical part is termed as functions, because for each x value there is a unique y value. X value represents the domain, y value represents the range. So f of x is equals to x. When x is equals to 0, y is equals to 0. X is equals to 2, y is equals to 2. X is equals to 4, y is equals to 4. So followed by x is equals to minus 2, y is equals to minus 2. So when we arrange all this in a table, like if we arrange a table in terms of graphical part, this is your x and this is your f of x is equals to x. When x is equals to minus 1, this becomes minus 1. 0, 0, 1, 1. So followed by 2, 2. When we arrange all this point on the graph, we will be getting a same straight line which is passing through the origin. So this is the graphical part for identity function. So next we will be discussing about constant function. So constant function, when f of x is equals to c. So the graphical part, it will be like parallel to x-axis. All this part is called the constant function. F of x is equals to c means what? Here f of x is equals to 3. So if you arrange f of x is equals to 3, when you table a graph in such a way, x and f of x, so for every x value, x is equals to minus 2, f of x value is 3, minus 1, 3, 0, then also f of x is 3, 1, it is 3. For every values of x, the point is coordinating to 3. So when we plot it, it forms a straight line which is parallel to x-axis. So this is the graphical part for a constant function. Next we will be discussing about polynomial functions. So here in polynomial functions, you are very clear about the definition of a polynomial function, where f of x is equals to a0 a1x plus a2x square plus a3. It goes on till an x to the power n. This defines a polynomial part which you learned in your 10th standard and your lower classes. Polynomial functions, which is nothing but when we are restricting to this part, this is called constant polynomial. This is called linear polynomial. When we are attaching till x square, that is called quadratic polynomial, x cube, cubic polynomial, it goes on. So see the examples of two polynomials. Here it is a quadratic polynomial. F of x is equals to x square. It is nothing but a parabolic upward parabola, and this is a cubic polynomial where it is intersecting the origin. So these are the two graphs which represents your polynomial equations. One is quadratic form, another one is cubical form. Then we will be proceeding on to the next type, that is called rational functions. So rational functions. So here rational functions which is in the form of p by q. So here it is in the f of x and the denominator will be g of x, where g of x is not equal to 0. So this is the definition for a rational functions, and the rational functions, how it is being depicted on the graph. Okay, you can plot the graph. For example, 1 by x, it is a rational functions, provided f of x is equals to 1 by x. It will be a graph like this. Okay, so likewise we can depict the rational functions on the graphical part. And then comes modulus function. So what is a modulus function? Suppose f of x is equals to a real function, real number to real number, and f of x is equals to modulus x. And this modulus x is defined as plus x when x is greater than 0, minus x when x is less than 0. For every value of x, your f of x will be a strict positive number. That is called modulus function. Look at the shape of a graph, how it is being coordinated. For every negative numbers, even for minus 6, every number, there will be a unique positive number in the y-axis. So this is what modulus function graph. Then signum function. So what is a signum function? So f is a real functions, provided it is defined as f of x is equals to, the definition of a signum function is nothing but f of x is equals to modulus of x divided by x. This is what the definition of a signum function. If any value of x, if it is written in the modulus form, let it be, for example, in the graphical part, if you are allotting x value on f of x, if x is equals to suppose minus 1, if you put over here in the modulus of minus 1, it becomes plus 1, denominator it is minus 1, therefore plus 1 minus 1, the answer is minus 1. And then if you put x is equals to 0, then the value is 0. Then if you put x is equals to 1, then the value becomes 1. Not only that, if you extend the result to 2, 2 divided by 2, it becomes 1. For any value of x, so here the x value belongs to real number, whereas f of x, it belongs to the limiting of numbers minus 1, 0 and 1. This is a range for f of x for a signum function. And look at the graph. So it is when x is equals to any value, the y value will be in terms of y is equals to 1, f of x, then 0, and then for x is equals to any negative numbers, it leads to the range leads to minus 1. So this is the graphical form for a signum function. And then greatest integer function. So what is greatest integer function? So it is termed as f of x is equals to, denoted as box bracket of x. But this is what greatest integer function, where x, the domain actually belonging to real number, whereas the range which is actually belonging to all the integers, because that is what greatest integer functions. Be it 2.7, it will be taking only the positive integer number, or the integer, nearest integer value, or even minus 2.8, it takes the nearest integer as minus 2, or 3.75, it takes only 3. So this is what greatest integer function. So for any value, it takes minus 1 for minus 1 to 0, 0 for 0 to 1, and 1, the greatest integer between 1 to 2. So look at the graphical part. So between 1 to 2, it takes value only 1. Between 2 to 3, it takes only this value. It will not reach any of all this decimal place. It takes only 1 point, that is what? 2. Okay, so that's why domain belongs to real number, whereas range is belonging to integer. This is what greatest integer function.